My name is John Patch, and I'm with Real-Time Innovations. And today I'll be talking about an integration effort we did with OAR, integrating our two TSS capabilities into the face BALSA data model or BALSA example. Yeah, so we integrated our Connects TSS with the Online Applications Research Corporation RAID TSS implementation into the BALSA demo. We worked very closely with them. They were extremely helpful throughout the integration effort. And the point of the demo was to prove that via the TPM capabilities as specified in the FACE technical standard version 3.1 that this integration could be done successfully. Of course, there's other reasons to use TPMs, but this one was specifically designed, this demo was specifically designed to show the approach of integrating multiple TSSs. Now, why was BALSA chosen? It integrates many, if not all, the FACE segments, the OSS excluded, but it provided a very open environment. There's source code available, is well understood. And so, like I said previously, we had already separately integrated our TSSs into that demo. Okay, so here's the picture of the boundary diagram. I ripped this diagram out of the FACE technical standard edition 3.1. You can see that we have integrated into the transport services segment piece of the FACE boundary diagram. So again, on the top, we've got two components, or I'm sorry, on the right, we've got two components of the BALSA demo. The first one is the portable component segment, the ATC manager application. That was based on, we left OAR's RAID TSS as the TSS for that application. And we've got the OAR RAID TPM capability alongside the Connects TPM capability underneath. And so the Connects TPM capability was used to interface with the BALSA platform specific services segment, the EGI data application. This is based entirely built on Connects TSS with the TPM then communicating to the ATC manager. So what were the integration steps? So BALSA, again, provided a very nice, convenient environment to do the integration effort. We needed to standardize on a single FACE strings and sequences implementation. This is important because the data model that we use, the BALSA data model, includes strings and sequences. And so just to keep things straightforward, we just standardized on a single version. Typically, Connects TSS provides an implementation as well as OAR RAID. RAID provides an implementation. So strings and sequences aren't a FACE capability in and of themselves, but they can be plugged in. The interface to strings and sequences is standardized, and so we're able to just adopt OAR's implementation of the strings and sequences to keep things simple. The second integration step was to map the TPM's type abstracted messages to the TSS's type-specific interface. So we've got that mapping. As messages come into the TPM, they need to be mapped to the specific TSS type-specific interface based on the message GUID. And then finally, there's an implementation of the TPM data callback handler. So like the TSS, a TPM can handle incoming messages either via polling or data callback. And so the BALSA and specifically OAR's RAID use the callback at the TSS layer. And so we implemented data callback at the TPM layer as well. Okay, as I mentioned previously, the FACE strings and sequences libraries are interchangeable. We showed by integrating the OAR RAID strings and sequences library into Connects TSS. There are some things to consider if you need to go this route. It's a fairly straightforward practice or just process, assuming that the strings and sequences implementation are complete and correct. But there are a couple potential pain points with the integration. The first one is when you're integrating your TPM, since it all links into a common application, you need to make sure all of your include paths are lined up. So you can't accidentally include one strings and sequences header from one vendor and implement their or link to their library during the link stage. So if there are inconsistencies there in the include paths or the header files that are included, they will come up as subtle errors while you're testing when you're actually testing your application. The final point to consider is that linking to a new strings and sequences library will change your application binary. So if there's any issues with that, if the binary has certification artifacts, DO178C certification artifacts behind it, there will have to be some type of delta cert included in the final certification. So just be aware of that with the strings and sequences. And again, it was determined to be because the strings and sequences were being passed up the chain from the Connects TPM to the OER RAID TSS. It was just easier and more straightforward to use the same implementation throughout the call stack. This next one may or may not be an issue. So we have this message GUID. As I mentioned before, a message coming to the TPM is not type specific. There's no type specific interface within the TPM. And so there needs to be a way to map a incoming TPM message to the proper serialization and or deserialization routine. And that's done via this message GUID. So as we integrate multiple TPMs and different messages are coming into the TPMs, there needs to be some coordination of these GUIDs to make sure they're consistent. GUID is recognized commonly across the entire application, not just within a specific TPM. And so that coordination, there's really no guidance in the spec currently showing how to map these GUIDs to, or have this consistent interpretation. So it's left up to the system integrator. I think a previous presentation that talked about how intelligent and great these system integrators are, and I completely back that. We just need to make sure that they're aware that they have this extra responsibility of managing these GUIDs properly. And now we come to the data callback handler. So as we talked about, we can handle data either synchronously by polling or asynchronously via these callbacks within the TPM as well as the TSS. Ideally, both the TPM and TPMs and TSSs will agree on whether or not callbacks or polling is used. In the case there is a mismatch, then we need to make sure that, for example, if we've got a callback, a message coming into the TPM is handled via callback, we need to make sure that that's able to be made available to the TSS if it's polling. And there's really no way to do that within the TPM or TSS directly. So in the case of that mismatch, there's going to, again, this is going to fall back onto the system integrator. There's going to have to be some coordination or some maybe service that will enable a callback to match up correctly with a polling mechanism or synchronous message handling. So I've got a little diagram there at the bottom of the slide. We show that the incoming message from the transport. We got the TPM data callback handler. Within that handler, that's where the deserialization routine is plugged in. And then in this case, we do have a match of callbacks used by both the TPM and TSS. So we're able then to invoke the TSS callback directly. And then it can pass that information up to the application. So again, if there is a disagreement on whether or not data is handled synchronously or asynchronously, it'll be up to the system integrator to create a service or some kind of mechanism that will handle that inconsistency. A couple things more to consider. Now, we didn't necessarily have to do or make these considerations during this integration of the Balsa demo. However, it could pop up during actual application integrations. I think the biggest one here would be a mismatch of languages. So we've got the face C and C++ APIs. I think they're probably, at least in our experience, the most commonly used face APIs. And so when we look at mixing and matching C++ with C, we look at differences in return codes. C obviously doesn't have a concept of namespaces, and that's the purpose of the TA type abstraction, is to handle that lack of namespaces in C, but C++ does, they heavily uses namespaces, especially with function overloading to implement the type-specific APIs. And so we need to look at mixing the two, the differences in return code values or constants potentially, as well as these function definitions. You need to be very careful that TPMs, as we integrate more and more components into the application, that there's a matching of the data models. The type definitions are mismatched, or there's some kind of different understanding between the meaning of the data coming in that could introduce very subtle and difficult to debug issues within the application. So when the final integration testing is going on, type definition mismatches, namespace mismatches, etc., could introduce very subtle and difficult to debug issues. Then finally, when we're looking at mixing up face C and C++ APIs, there's going to need to be some management of the different type abstraction and TPM configurations. So there's each TPM is going to have its own configuration requirements, as well as the type abstraction. So you'll need to, or the system integrator will need to make sure to manage those configuration deltas accordingly. So in conclusion, the integration effort is reduced if everyone agrees on the details that the FACE technical standard does not define. Again, we got the GUIDs and the mapping of different FACE languages, as well as what to do if there's a mismatch between the synchronous or asynchronous handling of data. So as long as all those details are agreed and sorted out beforehand, that will help the integration effort immensely, at least in our experience. Also, make sure you have consistency across all the applications. That's data models, namespaces, APIs, etc. Ideally, everything would match up and be consistent. However, if there are unmanageable inconsistencies, then they'll just have to be accounted for in some way. Also, we took the easy case. The Balsa demo is very straightforward, well understood, open. You know, and it's not very super complex. So we imagine that in actual real-world integrations, some other issues may come up that we haven't identified here, but just be prepared that there could be some significant integration effort and subtle issues or errors that need to be debugged. Thankfully, not many of those were encountered during this demo. However, we do anticipate there will be additional complexities once the real actual systems are integrated. And that brings me to the end of my slides. Any questions?